Hello, I'm Dr. Jeanette Stingone of the Department of Epidemiology here at Columbia University. This video is part of our machine learning series to serve as an introduction for public health scientists. Let's talk a bit about some of the major challenges you might face as you start out with the machine learning analysis or application. The first is the potential for misalignment between your research question and the method you're choosing to use. Often in public health and epidemiology, we're interested in the research question of, does X cause Y? Or to be more specific, does intervening upon X affect Y? Most machine learning methods, on the other hand, have been designed to answer the question, does X predict Y? Or maybe even not going that far, just how best can I predict Y? And we don't even know that much about X. That's a really important point to think about before you even start a machine learning analysis, right? Just because something predicts an outcome of interest does not mean that it is a cause. If you're using machine learning approaches, even though you're interested in causes or associations, you're making that assumption that because something predicts Y, it is more than likely a cause. And that's a big assumption, and you really need to think about whether that fits for your context. The second piece of this comes in our interpretation of results. If you run a machine learning analysis and you see that X is a very strong predictor of Y, it doesn't really fit to then say, well, if we intervene upon X, we can decrease Y, some adverse health outcome, right? Because that's, again, not what these methods were designed for. So you really want to think both at the design stage, does it make sense for me to use this method for my question of interest? And then also at the interpretation stage, am I interpreting these results within the limitations of what these methods can and were really designed to do? The second challenge that is often faced, it's sort of a double challenge, is data quality as well as representativeness. And these are really two different things. When we think about epidemiology and public health, we often, always, think about measurement error, right? Are we measuring things correctly? And are the variables that we have measured good constructs for what we're really trying to understand? Both of those things will also impact machine learning, okay? It doesn't matter how big your data set is or how many values you have, those same issues can apply. And so you really want to think about, maybe you do have a lot of data from some specific source. Is it still high quality? And if it's not, how might that impact your results? The second piece of this is representativeness and thinking about who is in your training data. This becomes really important when we think about concepts like algorithmic bias. We know that many of our data sources are affected by systemic biases, things like racism, sexism, right? All of those types of things. That's baked into our data because it's baked into our society. And so we have to think about the sources of our data, who is represented, how might some of those biases be in those data, and how might that impact our model development and then model use. All of these things need to be carefully considered before you really ever get to a stage of running algorithms using software. The last challenge I'm going to talk about is interpretability. Interpretability of a model comes up a lot. The figure I have here on this slide of having some input, it goes through a black box and then you have your output, I think is something that's commonly discussed, okay? This idea of, if I'm not sure what the model is doing, how do I know that I'm getting the right things? This also, or the right, not just the right predictions, but I'm getting the right predictions for the right reasons. And that goes into this idea of, if I want to use my model later on, I want to know that I've got some kind of stability and I want to understand how my predictions are being made. This interpretability varies by algorithm. And so you really, again, go back to that research question. How important is interpretability for you? The other issue about interpretability, though, is related to accountability. These models, if they're being used for decision-making purposes, well, there has to be some accountability. And if we're not sure how the decision is being made, right? Then how do we know who's accountable if that decision is wrong? Or how do we even know if the decision is wrong? This has been discussed in the literature extensively when these types of algorithms are used for deciding who gets what resources. And again, going back to that issue of data representativeness, data quality, right? If we are perpetuating things that we've done before by the use of these models, how will we know that if we don't have transparency, right? So this is not just the transparency of the algorithm, but also the transparency of the process of putting that model together and using it in populations. All of those are really big challenges that we need to think about before we start using these approaches. The last piece about interpretability and why it's so important is because as we use models, again, for clinical decision making or for making predictions, there's a strong possibility that making those predictions will affect either healthcare, public policy. It affects the system we're trying to study. In which case, our model might not behave the same way as it did in the beginning. This is why you'll often hear people talking about the need to constantly monitor and evaluate the models over time to make sure there's no drift, to make sure they're working in the way that they were before. A lot of that depends upon interpretability, right? Knowing what the model is doing and why, and how it could potentially change, based on its implementation. So again, all of these things are challenges you want to think about, before you start your analysis, while you're in the analysis, and then as you're interpreting results.